Section 4.5 Graphs of Sine and Cosine. Graph of sine x. Sine x is periodic and has a period of 2 pi, meaning that if you start moving from a point P of xy on the unit circle, after traveling 2 pi distance on the unit circle, you will be back at point Pxy. We will graph sine function on the interval 0 to 2 pi, and the rest of the graph will be made up of repetitions of this portion. So here's a table. So to graph sine of x, so the top row has a values of x and the bottom row is the values of y. So if x is 0, we calculate sine of 0 is 0. If x is pi over 2, sine pi over 2 is 1. And if it's pi, sine pi is 0. And if it's sine 3 pi over 2, sine 3 pi over 2 minus 1. And if it's 2 pi, then sine 2 pi equals 0. So it looks like you start with 0 on the x-axis, you go above x-axis 1 unit, and then you come back on the x-axis and then go 1 unit below x-axis, and then you go back to the x-axis. So here is a graph of sine. So let's see, when x is 0, it says sine of 0. Pi over 2 is 1. And when I say x is pi, sine of pi is 0. And it's 3 pi, sine of y is minus 1. So this graph. And then you just go back on the x-axis, then you go 1 unit up, and let's keep repeating. Similarly, on the left side, it has to go 1 unit down, and then you go back to x-axis, and then you go 1 unit up. And just keep going, just keep repeating this one. General form of sine function, y is equal to d plus a times sine b of x, b times x minus c. A is the amplitude, so it's absolute value. Amplitude is absolute value of the coefficient of sine function. Period is the time it takes to complete one cycle and is equal to 2 pi over b. And b is a number of artifacts here. Phase shift is x equal to c over b. So how do you get this one? Well, to find the phase shift, you set the argument of sine, which is bx minus c equal to 0, and solve for x. You will get x equal to c over b. So if c over b is positive, then you shift right. If c over b is negative, then you shift what? Left. Frequency, the number of cycles completed per unit of time, and is equal to b over 2 pi. Example 1, finding the period and the amplitude. So let's say determine the amplitude and period of the function, then graph the function for one period. So here is the equation, y equal to minus 2 sine 0.25x. So this is of this form, f of x equal to a times sine bx. So a is negative 2 and b is equal to 0.25. That's b. So amplitude is, take the absolute value of a, so it becomes, the absolute value of negative 2 is 2 because a is negative 2. So the amplitude is 2. Period b is 2 pi over b, that's the formula, and the b is 0.25. So we substitute here, so we get 2 pi over 0.25, we put on the calculator, so it becomes 8 pi. So this sine has a period of 8 pi. So here is a graph. So the graph of cosine x. Cosine x is periodic and has a period of 2 pi. So to graph cosine function, we will create a table. So we choose 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the cosine x, then cosine 0, 1, pi over 2 is 0, and then cosine pi is negative 1, cosine 3 pi over 2 is 0, and cosine 2 pi is 1. It looks like the graph of cosine is, it start with a 1, and then it come back to x-axis, and then it go below x-axis 1 unit, and then you come back to x-axis, and then go 1 unit above x-axis. So here is the graph of cosine of x. So this point is when x is 0 and y is 1, and x is pi over 2, y is 0, when x is pi, y is what? Negative 1, and when x is 3 pi over 2, the y is 0, when x is 2 pi, the y is 0, when x is 5 pi over 2, the y is 0. So this is the graph of cosine x for one cycle. And then you can extend, you go to the left. So it's above x-axis 1 unit, so you have to come back to x-axis, then you go below 1 unit, x-axis, and you come back x-axis. Similarly on this side, it's above x-axis, you go back to x-axis and then go below. So this is the way you get the graph of cosine of x. So the general form of cosine function is y equal to d plus a cosine bx minus c is an amplitude of absolute value phi. A is the number and this coefficient of cosine. Period is the time it takes to complete one cycle and is equal to 2 pi over b. You have to remember this one. For sine and cosine is 2 pi over b is the period. The phase shift is c over b, and to calculate and find this phase shift, you set bx minus c equal to 0, and then solve for x, you get x equal to c over b. The frequency is number of cycles completed per unit of time and is equal to b over 2 pi. So it looks like this is the reciprocal of this, the period. Example 2. Determine the amplitude, period, and the phase shift of the function. Then graph the function for one period. So here's the function, y is equal to 4 times cosine 2x minus pi. So first find the amplitude. So the 4 is a and the b is 2. And so the amplitude is absolute value of a, which is absolute value 4 is 4. Period is 2 pi over b, b is 2. So we got 2 pi over 2 becomes pi seconds. So phase shift is to find phase shift is set to x minus pi equal to 0. Now take the minus pi to the right and divide by 2. X is equal to pi over 2. Now you can use graphic calculator, but here are a few hints. You can graph from 2x minus pi 0 equal to 0 to 2x minus pi equal to 2 pi. So you solve for x, so x equal to pi over 2, and then solve for x, this will give you, because you take the pi to the right, it becomes 4 pi, 3 pi, and then divide by 2, 3 pi over 2. And then you find increments, period is divide by 4, that's the formula. To become period is pi, you found earlier, pi over 4. Now we develop a table. So here's the table. The top row has x values. We start with pi over 2 and then add the increment pi over 4 into pi over 2 and simplify, get 3 pi over 4, and then into 3 pi over 4 we add pi over 4, we get pi, and then we add pi into pi, add the increment pi over 4, it becomes 5 pi over 4, and then 5 pi over 4 add into pi over 4 gives you 6 pi over 4, which is 3 pi over 2. So now we substitute these values, x equal to pi over 2 in y equal to 4 cosine 2x minus pi. So it becomes 4 times cosine 2 times pi over 2 minus pi. 2 cancels, you get the pi minus pi 0, so cosine 0 is 1. So it'd be 4. And then we substitute 3 pi over 4 with the axis here. It becomes 4 times cosine times 3 pi over 4 minus pi. So let's say simplify to pi over 2. So if you add this, subtract these two, and cosine pi over 2 is 0. So it looks like when x is pi over 2, the graph is above 4 units above x-axis, then comes back to x-axis. So since it's periodic, so then the graph will go 4 units below x-axis, and then it comes back to x-axis, and then it will go above 4 units above x-axis. So we plot those points. So when x is pi over 2, this is y is equal to 4. So when x is pi over 4, then 5 pi over 4, then it becomes negative 0. And then when it becomes pi, it becomes a negative 4. And for 5 pi over becomes 0 again, and 3 pi over 2 becomes 1. So join these 2 points, this is the graph of one period. And then after that, it goes down, and it goes up, and this can keep repeating. And that's the graph. So here is an example 3. Is a write an equation for a function with given characteristics. So a sine curve with a period of pi, an amplitude 2, a right phase shift of pi over 2, and vertical translation up 1 unit. So we can use, we can start with the general form of the sine function. And it's a y is equal to d plus a sine bx minus c. So the amplitude is 2, it means a is 2. And the period, to find the value of b, we use the period. The period is pi, and the formula is 2 pi over b. So now we solve this equation for b. So multiply both by b, to become b times pi equals b times 2 pi over b. b is cancelled. You get b times pi equal to 2 pi. Now divide by pi. So it becomes b times pi over pi equals 2 pi over pi. Simplify, b is equal to 2. So to find c, we use phase shift, which is the formula c over v. And the phase shift given is pi over 2. So we have c over 2, and b is 2. So it becomes c over 2 equals to pi over 2. Now to find c, we multiply both sides with 2. So we got 2 times c over 2 equals 2 times pi over 2. 2 cancels. You get c, and 2 cancels gives you pi. So vertical translation up of 1 means d is 1. And the formula is y is equal to d plus a times sine bx minus c. So now we substitute a is equal to 2, b is equal to 2, and c is equal to pi, and the d is equal to 1. So this becomes 1 plus 2 sine, 2 times sine 2x minus pi. So example 4, write an equation for a function with the given characteristics. A cosine curve with a period of pi, an amplitude of 1, a left phase shift of pi, and a vertical translation down 3 over 2 units. So we start with the general form of cosine, which is y equal to d plus a times cosine bx minus c. So the amplitude is given is 1, means a is 1. So the period is pi, so we're going to use that one to find the value of b. So we write period is equal to pi, and the formulas for the period is 2 pi over b. So now to find b, multiply both over b. So it becomes b times pi equals to b times 2 pi over b. b cancel. You get b times pi is equal to 2 pi. Now divide by pi. So it becomes b times pi over pi equal to 2 pi over pi. pi's cancel, b is equal to 2. Now to find c, we use the left phase shift of pi. Phase shift is c over b, and say left, so be negative pi. But b is 2 we calculated earlier, so this becomes c over 2 equal to minus pi. So to isolate c, multiply both sides by 2. 2 cancels, so it becomes 2 times c over 2 equal to 2 times negative pi. 2's cancel, so you get a c and it becomes negative 2 pi. So c is negative 2 pi. Vertical translation down of 3 over 2 units means d equal to negative 3 over 2. Now we write the formula y equals to d plus a cosine bx minus c. Substitute a is 1, b is 2, c is negative 2 pi, and d is negative 3 halves. So this becomes negative 3 halves plus 2 cosine, b is 2x, c is negative 2 pi. So negative negative become positive. So the equation is y equals to negative 3 over 2 plus 2 times cosine 2x plus 2y. So example 5, for a person exercising the velocity v in liters per second, a fair flow during a respiratory cycle is given by this formula v equals to 1.75 sine pi t over 2, where t is the time in seconds. So first we're going to find the time for one full respiratory cycle. So basically we're looking for the period, okay? And the formula for period is 2 pi over b. So the b from this equation is pi over 2. So we substitute here, so we get 2 pi over 2. It becomes 2 pi times 2 over pi. So it will be 4 pi over pi 4 seconds. So the respiratory cycle, for one cycle, the time is 4 seconds. For a person exercising, the velocity airflow is given. What is find the number of cycles per minute? So b is equal to pi over 2. We're looking for a frequency. The frequency is b over 2 pi. We substitute b is equal to pi over 2. So it becomes pi over 2 times 2 pi, and then becomes pi over 2 times 1 over 2 pi. So pi cancel gives you 1 over 4, 1/4 cycles per second. Now we multiply 1/4 cycles by 60, so it becomes 60 over 4, 15 cycles per minute. So here's a graph. So you can use graphic calculator, so you will get this graph. Run this. Okay, here's an example 6. We are given a function p equals 100 minus 20 cosine 5 pi over t over 3, and that approximates the blood pressure p in millimeters of mercury at time t in seconds for a person at rest. A, find the period of the function. So we start with the equation v is equal to 100 minus 20 cosine 5 pi t over 3. So b is equal to 5 pi over 3. So the period is 2 pi over b, so we substitute b equal to 5 pi over 3. So it becomes 2 pi over 5 pi over 3, which is equal to 2 pi times the reciprocal of that, 3 over 5 pi. So now we simplify, exam 6 pi over 5 pi, which is 6 over 5 seconds. Next, we're going to find the number of heartbeats per minute. The number of heartbeats is equal to the number of cycles per minute. So we are here looking for frequency, and from part A we've found period is 6 over 5 seconds. Now the frequency is 1 over the period. So we substitute the period 6 over 5. So it becomes 1 over 6 over 5, which means equal to 1 times the reciprocal of 6/5 and 5/6. So it becomes 5/6 heartbeats in 1 second. Now we multiply 60 seconds, so we become 5/6 times 60, become 300/6, which is 50 heartbeats per minute. Example 7. We're given a graph, and this is a graph of this kind of function, f of x equal a cosine x plus d. So we have to find a and d. But to find a, locate the highest point. Highest point is here 6 curve, and then locate the lowest point. So the lowest point is like in -2. So a basically is amplitude basically is not 6 or not 2. So it's somewhere in the middle. So we 6 subtract -2, so it becomes 8/2 is 4. So a is 4. Now we find a d. So d basically is the vertical shift, because looks like this graph is shifted up. So it looks like it's shifted 2 units up. And to find that one, you can use this formula, highest point minus a. Highest point is 6, and the a we determined 4. So 6 minus 4 equals to 2.